Hello, Emma.
Is Amy Lynn coming?
I think so. Sometimes she's a minute late. I haven't heard anything that she wasn't coming, but at least we're filming today and she's not. So, okay. I have not graded your corrections yet because I like to sit down and grade everything at one time, and I have nothing else to grade this week, so I just decided that you guys would be okay waiting another week for those corrections to come back. So I hope that's okay. I hope that doesn't mess you up too much. And also I wanted to tell you guys that because registrations, I guess maybe starts today.
Today.
I think it's due today. It was due today. Since I'm not registering kids, I'm not totally up on it. But was thinking about my group for next year and thinking about you guys and just thinking that I don't think there's any way I could have a group as good as this group next year. Like, I just feel like that would be impossible, and maybe I will, but y'all have been an amazing group. Like, you're my guinea pigs. Thank you for bearing with me as I'm learning how to do this. But I just feel like I have just the perfect class. You're just smart and enthusiastic, and you bring energy, and you make it fun and easy and make me want to do it. So I'm just very thankful. I think God knew if I was going to do this more than 1 year, that He had to give me a good group, and He gave me a great group. So thank you guys. Oh no, I forgot my pens today. Sharpies.
You can borrow mine.
My board writing.
Never
There's
mind,
one
you
on
can't
here.
borrow one of
Okay,
mine.
here's one of these. Okay. How was the test? It was good? Okay. Well, I have some other news that I think you'll think is great news. I told Jennifer Crocker on the phone this morning. She was happy about it. Okay, so I was thinking about Module 14 and spring break coming up. And I know a lot of you are very busy with running right now, and the honors kids are working on their papers. So I'm trying to make things a little simpler. I really want you to take the test before spring break and have a break. So I thought about Module 14 also, and I'll be completely honest with you, I'm really busy too, and I'm kind of tired of doing Quizlets. So it's not just for you, it's for me too, it's for everybody. What I decided to do for Module 14, we are not going to have Quizlets, okay? And so if you're somebody like Solomon that loves Quizlet, that's a bummer, I really learned well on Quizlet, you can get on Quizlet and just search Apologia Biology Module 14, and other people will have done Quizlets. They probably won't be as detailed as mine are, but you can still study terms that way if you want to, but you really don't have to. The Module 14 test is coming straight from the study guide and Appendix B. So as far as I'm concerned, the only thing that you have to study, if you know and understand the answers to the study guide and the answers to Appendix B, and there may be something, and I'll tell you this next week, like there's a figure in the book that really applies to one of those questions, like you may want to go back and review that figure. But I'm going to take the test straight from the study guide and straight from Appendix B. How does that sound to everybody?
Amazing.
Oh, that's a good
you mean
thing.
like verbatim or like general?
Probably some verbatim and some not verbatim. And especially, I would say with the honors kids, I will have some discussion stuff and I'll take it. I probably won't make it verbatim, but I will make sure that when I'm writing the questions that someone who just studied those two things should, and was paying attention in class, should know what the answers are, okay? Again, stay on task. Get that test done Friday. Okay. The other thing is for honors, I had the due date for the paper for the Thursday when we get back after spring break. I am going to give the option so that is
The 26th.
the what?
Is it the 26th? No, it's the 14th.
Oh, I thought
The
it was
14th, the 14th. I can't look at my phone to know what the date is.
Also,
since I'm filming.
is it, so on the directions it says 3 to 4 pages, it needs to be 3 to 4 pages long, is that 3 to 4 full pages? Or it's just
I mean,
like-
at least needs to be 3 full pages, yes. Yes, okay.
It's
And remember, when you do your citations in there, that takes up space.
Oh, so the citations count.
Yeah,
well, like in text, not the words.
not the works
sentence.
cited, but that
Okay.
takes up space in your text, so that makes it a little bit longer. Okay, that's gonna make it be a little bit longer. Okay, so you may turn it in that Thursday after spring break, which we're not totally sure what that date is, and I'm sorry that I can't look it up on my phone.
Well, spring break is the 6th, so it'll be the 14th.
Okay. Or you may email it to me by the following Tuesday, which is April 18th. Okay, so you can either bring it to class on Thursday, or I'm giving you like an extra weekend in case, because I want you to take time off over spring break. So if you need that extra weekend, the final date that it has to be in by is it can be emailed to me by Tuesday, April 18th. If that's helpful to anybody. Okay? Then we have your presentation part of that. Okay? And so the dates I have to do the presentation are April 20th, April 27th, and May 4th. Okay? And so I want you to pick out, we need to get signed up for the dates that we're gonna do the presentation. I can't have more than 2 people on one of those days. Okay? So April 20th, which would be not the Thursday right after spring break, but the next Thursday.
Can you do that one?
That's what you want? Okay, so
As
let
long as
me,
you're cool with that.
we've got
I'm fine
April
with that.
27th. So that's, you're taking April 20th. And 2 people can take April 20th. Oh goodness, I don't even have a pen. I didn't bring my bag of all my pens. Does anybody have a pen that I can borrow for today? So sorry. I have some, goodness gracious.
I have one, colored pencil. Is it, do you like a pencil?
Anything will be great, thanks, Sam. Okay.
I'm
Okay,
at Amazon, I'll do the 26th. I think
so
it's
27th.
I think it's 26th.
Am I wrong? You think it's the 26th?
Is it? Because I think the 27th is the fall, and that's a Friday.
No.
I think,
No, it's on 28th.
Oh.
I think it's the 27th. Okay, so you guys are doing that second week. Okay, so Emma and Ellery. So Amy Lynn, that leaves you with May 4th or April 20th.
May.
Okay. Okay. Okay, what, and Solomon and Miranda, forgive me for talking honor stuff.
No, we're okay.
Okay, we have a little time to do that today, so what else has everybody gotten done on the papers?
I pretty much have incidents down.
Okay,
Like a full paragraph.
okay, okay, so you've been working, okay,
I have a plan for what I want to do. and
Like
then I
your-
find-
kind of like your outline?
Yeah, like what I want each paragraph to say, and then I have an applicant choices.
Okay, good, okay,
I like went back to what sources they came from. So like
okay.
per not necessarily paragraph, I did it per prompt.
That's how I would have done it
So then
too.
I can look at the amount
Yes.
and decide what needs to be paragraph.
Yes.
So I did it per prompt and then.
Okay,
And then I kind of had a question about the peer-reviewed article.
Mhm.
I think I found what I want, but I can't figure out how to see the whole thing.
did you talk to
So
Ellery about that?
PubMed is all peer-reviewed journals. And you go to PubMed. I know, and I like typed it in and I found one. You have to put the filter on. I did that too. Well, just okay, when you see, okay, yeah, I can show you. But so I have all of the sources.
Okay, and you can do this too, Emma, you can send me it, you could, email me the link to that one and I can get on there and see. Some articles you can't without buying them, there's like some certain stipulations, so I may need to look at it, but also talk to Ellery about it.
Well, and I did like you can filter it where it's only free, and I did that too,
Uh-huh.
like where you don't
And
have to buy
so
it,
you-
and I still couldn't figure out how to
Okay.
open it, so.
Okay, I may need to play with it, but I'll also get
Okay.
Ellery to look at it. Okay. Any other questions about that? And remember, for your presentation, you need to have some kind of visual aid. Okay. All right. Okay, then, what else did I want to say? I think that's it. Okay. Other thing I want to tell you guys is, oh, Amy Lynn, go ahead.
I don't know if you said this,
It's okay.
but what is the presentation about? Like, is it about the research?
It's on, go back and read your handouts I gave you. Yes, it's about your disease. Yes, it's, I think it tells, and I can't even, it's, so you got a sheet on there about the research paper and presentation. Yes, it is about your paper. It is about your paper. Let's see what it says on here. I cannot even remember exactly what I said about the research paper.
I think I have it somewhere, but
So I.
You will do a 6 to 8 minute presentation for the class covering the information from your paper. You will need to include a visual aid as part of your presentation. And that's it.
So I kind of had a question. Will we like be reading our paper, or will
No.
we just kind of go over like the
Definitely do not read it.
Okay.
Yes, do not read the paper. You're gonna go over the highlights, and even if it's 5 minutes, let's say it needs to be at least 5 minutes and no more than 8 minutes, okay? But it is, it doesn't need to be as technical as your paper, because you're just educating your peers about that disease and making sure that they understand about that disorder.
Does visual aid include like a handout?
A visual aid can be a handout.
Okay.
It could be a poster. I'm totally fine with a handout. It could be a poster, it could be a PowerPoint. I mean, of course I feel like we're limited technology wise down here with the internet, so don't be dependent on the internet. But yes, a handout is fine. It does not have to be some elaborate, visual aid.
And then also, I guess if we had like, I don't know, a trifold or something, we could kind of
Yes.
use that to help us.
I
But
try.
are we allowed to have like a sheet of paper with certain facts?
Oh,
on it,
yes,
whatever
oh, yes,
it was
put your
there?
stuff on index,
Okay.
yes. Yeah, I don't expect you to have the whole presentation memorized. I mean, it'd be good if you're not sitting there reading from your cards the whole time, you don't wanna do that. But yes, you definitely are gonna need something to be able to refer to and look down at. Anything else? You good? Okay, and again, if anybody needs me to come early next week, just message me. And I'm happy to come in and work with you. Okay. All right. I looked up the salmon, and it said that they will always attempt to go back to their birthplace, and that sometimes they'll die doing it. That they'll try so hard that they'll die doing it. But that some of them, if they can't get back to their birthplace, so if something happened, like that area had dried out or something happened to it, then sometimes they will find other salmon and they will go with other salmon. So,
Only if they know that it's like safe.
right, it will only be with other salmon, they wouldn't go like independently, it would be like a group.
That's funny.
And then I also read, a bunch of stuff about the farm salmon and kind of how it's done, and I still don't completely understand the spawning aspect of it, but it was really depressing. I'm just gonna tell you, it was just like that they put these like bat things like out in the ocean to like close them in, and a lot of it's off the coast of Chile, and just like thousands of salmon swimming up close to each other, and they don't develop the pink color because they're not in cold enough waters to kind of develop that natural pink color from the fat that their wild caught salmon have. And so they actually inject like dyes in them to give them the pinker color. And, it just said a lot of them end up getting, damaged because they're swimming into each other and they just, or like swimming in circles. It's just depressing. It's depressing to me. So I say eat wild caught when you can. Okay, all right. So we are in Kingdom Plante. So everybody can open up. And when we get to the point of talking about the leaf classification, I will have you show us your leaves and what you got. So maybe kind of have them out to the side.
So they're already in like my notebook, so I show you from
No, yeah, just have your notebook out and ready to go. Yes. Okay, so we are finally in a different kingdom. We're in Kingdom Plante. And what is the study of plants called? And what would be the scientist that studies plants called? Botany. Botanist. Okay?
That's not right.
All right. Plants are producers of oxygen, which we need to breathe, but do plants produce most of our oxygen? Aylin?
No.
No. Who does?
Plankton.
The phytoplankton. And who remembers this? This would really impress me. What kingdom the phytoplankton are from? Anybody remember?
Bonera, right?
No, not
Protista.
Protista. Good job. They are from Protista. Good. Okay. So we have different kinds of plants. We have plants that come back year after year that typically are going to have a woody stem. What are those plants called? The ones that come back year after year? Perennials. Okay. And what about the ones that just last for a year? Annuals. So those are going to be like your pansies that you plant. What about ones that last for 2 years? The first year they're storing food, the second year they're reproducing. Amy Lynn? Biennials. Okay. All right. And so this chapter goes a lot into different kinds of plant tissues, but one thing I want to make sure that everybody understands is that what tissues are, okay? And so we know, what is the building block of life? Miranda? Cells. Okay? So if the cell is the building block, a group of cells together are tissues, okay? So tissue is made up of a group of cells, okay? A group of tissue together makes up an organ, okay? And then several organs together make up an organ system, okay? So you've got cells, they're making up tissue, and let's say that they're making up the tissue that makes up your stomach, okay? And then your stomach, your esophagus, your small intestine, your large intestine, all that together is going to make up your digestive system. So tissue is just a group of cells, but we have different types of tissues that the chapter talks about in plants, okay? The chapter also talks about two categories of organs in plants. Does anybody remember what those two categories are, Ellery?
Chlorophyll?
No.
Or is that wrong?
No. Emma?
The vegetative and the reproductive.
Okay. vegetative and reproductive. And so reproductive is an organ that has anything to do with reproduction. So it's a lot of times gonna have seeds, okay? And then the vegetative is, any part of the plant that is not involved in reproduction, like stems, roots, and leaves, okay? All right, so typically, reproductive plant organs technically are all fruits, okay? But we don't always necessarily think of them as fruits because we think of fruits as being a little bit sweeter and having more simple sugars, more fructose in them. But any kind of food that you eat that's encapsulating seeds is technically a fruit. So, and I know you probably have heard that about tomatoes, that tomatoes are actually a fruit. But peppers would be the same way, peas and corn.
Bananas.
What?
Bananas.
Bananas?
Mhm.
I didn't think about that. You're
Whenever,
right.
yeah. I mean,
No.
Wait, bananas have a seed.
yeah.
Yeah.
Okay, so if you take a banana. and
But
you make
banana,
some
but
kind
we
of-
think of banana as a fruit.
Yeah.
Yeah.
Yeah, it's fruit.
Yeah, but I'm talking about
Like vegetables.
things that you think of as a vegetable.
So,
Yeah.
I used to think of it as a fruit. I mean, as a vegetable.
What
Sorry.
about like a
Bananas.
I would think
So pumpkin would technically be a fruit. Yes. So pumpkin, squash, all of those are technically fruit, but when dietitians are categorizing them, they're looking at them as a vegetable because they do not have like the same sugar content.
They taste bad.
Yeah.
Yeah, vegetables taste bad, fruit tastes good.
Yes.
So
Is
what's
that
that?
that weed is technically a fruit because it's like seeds?
What's a fruit? Everything.
I mean, I guess so. It's like we think of it as a grain, but it is like holding. You guys.
It's a fruit.
I know my group next year is not gonna ask me as hard of questions as what you guys ask me. Okay. Okay. All right, so now let's look at the tissues. Before you ask me any other hard questions, let's move on. Okay, let's look at the different kinds of tissues. So we have, what is the tissue that's usually in a single layer that's on the outside of the plant? What kind of tissue is that called? And it comes from our word for skin.
dermal tissue.
Dermal tissue. Okay, so derma, like the dermatologist, is the skin doctor. So you remember that anything with derma in it is going to be like an outer skin. Okay, so the dermal tissue is going to make up the epidermis of the plant. It is going to protect the plant from, protect the inside organs. It's going to protect the plant from bacteria and fungi. It's also going to be responsible for absorbing water and minerals. It's going to protect the plant from bad things coming in. Okay, so that is going to be the dermal tissue. What about the tissue of undifferentiated cells? What in the world does that mean? What are undifferentiated cells, Miranda?
Cells that have not specialized in any particle function.
Okay. So I think you can think of it like this. They are cells that are figuring out what their life mission is, okay? They have not figured it out yet, all right? They are trying to, they haven't decided who they're gonna be or what they're gonna be yet, what their career is gonna be. So what kind of tissue is that, Miranda?
Meristematic.
So meristematic, okay, and there's lots of mitosis. That meristematic, so mitosis, remember, is when the cells are dividing, making identical cells, okay? So lots of mitosis is going on, you're forming new cells, that's where growth is happening, but those cells still haven't figured out who they're gonna be yet. Okay, now what kind of tissue is the most common tissue where it performs a variety of functions? These cells have figured out what they're gonna do. They might store starches and oil. They may be involved in metabolism or photosynthesis. Solomon?
Ground tissue.
Ground tissue. So that's gonna be most of your tissue in your plant is gonna be ground tissue. And Amy Lynn, I think it's appropriate that you tell us about the next kind of tissue, since this is kind of like involves your dad in some way. It connects to your dad. What's the last kind of tissue?
Vascular tissue?
So vascular tissue, and what happens in the vascular tissue, Amy Lynn?
It is used to carry water and dissolved material throughout the plant. The xylem stuff carries the water and the minerals and stuff, and then the phloem carries the sugar and organic substances.
Okay, so
They're kind of like veins.
exactly. So is your dad a vascular surgeon? Okay, so he's a vascular surgeon. Okay, so we have veins. Plants have the xylem and the phloem. Okay, that's their vascular tissue. That's what carries substances throughout the plants. Those are like the veins of the plant. So that's going to be vascular tissue, and that was right. That was a great description of xylem and phloem. Which one between xylem and phloem do the cells actually die when they mature, and which ones do the cells continue to live after they mature? Emma?
The xylem die and then the phloem continue to live.
Right, exactly. Okay. All right, so now let's turn to page 14.1, and
What?
I'm sorry, page 431, figure 14.1.
14.
Okay, you know what is throwing me is I like to check time throughout class to make sure we're running okay, and because the clock's not on the wall and my phone is up there, can I borrow your watch to keep up here? Okay, thank you. Thank you so much. Okay. All right, perfect. Okay, so let's look at the leaf structure. And what is the primary portion of the leaf? What we think of the leaf, what is that part of the leaf called, Miranda?
The leaf?
No.
Maybe the blade?
The blade. Okay, and what is the tip of the blade called?
The apex.
The apex. And then what is the stalk of the actual leaf that attaches it to the tree called, Miranda?
Petiole.
Petiole. And then the tiny little leaf-like appendages kind of at the base of the petiole, they almost look like tiny little leaflets, and they're going to kind of cover that leaf when that leaf starts to form. Emma? The stipules. Okay. All right. I think we got that. And let's go ahead and turn the page to 432. And we've got, I think this is very straightforward, the simple leaf, which is just going to be one leaf attached to the petiole. And then we've got the compound leaf, which you're going to have a single petiole and multiple leaflets arranged on it.
So is that why when you see leaves, you don't automatically see the stipules, because it's just where the petiole is coming off of like the branch. It's not where each individual leaf is coming off the petiole.
Yes, yes. I feel like right now, because the trees are just starting to leaf back out, probably you probably are going to see it's probably an easier time to see the stipules right now too. If you want to look at some trees where the leaves are starting to leaf out, it's a really good time. I think that this curriculum organized that purposely put these plant chapters where they did, so that you would be studying the plants in the spring, so that you could see these things, because typically plants actually would come earlier, and every biology book I've ever done, plants come much earlier, so I like the way you did that. Okay.
In the next edition of this book, it's before, actually. It's
Oh, it
one of the
is?
first modules.
Oh, it is? I kind of like it. I kind of like where it is. All right, but you told me you didn't like the new textbook, wasn't it? So your brother does the new textbook?
He does it, and they did it a while ago, so
Okay,
they did this module.
okay.
Jack does different biology
Yeah, because he's at CC.
I feel like they're just in the earthworm like just now, like.
Mm-hmm.
They just
started
started
as
work. Yeah. I'm so glad we already finished that. just nice
It's
to
a lot of
share like a dissection.
I've been very
Yeah,
happy.
same.
with
I
it.
don't think so.
I'm glad we finished like the cells and like all the chemistry part of it. 'cause
I like that part.
That is always at the beginning of a biology class. So
That's
that
like the basics.
will always be. And actually, if you take biology in college, the first biology class is like what we did first semester, with minus Monera and Protista. It's basically everything from first semester without Monera and Protista. And then the second biology class is more like the rest of the class. So it is a little, it's very heavy on all that basic stuff about the cell and genetics and metabolism. Okay, so let's look down. We have the leaf mosaic is the arrangement of the leaves on the stem. So this is the way leaves are arranged off of the stem of the bush or the tree. And this section made me think about that statement I've told you guys before about how form follows function. Anybody know why that would make me think the leaf mosaics would make me think about form follows function? Like think about why leaves are arranged the way that they may be arranged on different trees depending on where the tree is in the environment.
Because it's arranged so that like the maximum amount of sunlight can get onto the leaves.
Exactly. Okay, that's a great honors test question. Anything in the chapter that has to do with form follows function and connecting why something would be, why God would have designed something one way, that's a great question right there. So yes, exactly, Naomi. It's designed so that you can capture the maximum amount of light. So the way the leaves are arranged, they're going to be arranged so that they can maximize the light to do photosynthesis. Okay. So that world design in figure 14.3, could anybody think of a plant that has that design?
Like, okay, hang on. I just forgot what they're called. But the red plant that we have at Christmas time. That's
Oh, the poinsettia. Is it that one?
yeah, because those are leaves, not flowers.
Huh. Okay. I have to go back and look at this. I think the world design, Amy Lynn.
I'm not sure about this. I don't even know if this qualifies, but a palm tree? Cause like the leaves are kind of just like doing that.
Well,
Oh yeah, I would say that is. Yeah, I would think that probably. Yeah, I think it's more common in with tropical plants. Like there's some kind of and of course I don't know the names of them, but just different tropical plants that you may see in Florida, or if you go somewhere more tropical, I feel like that world design is more common with those kind of plants. Okay, so now we're going to our leaf shape, and basically with these leaf shapes, this is kind of like going back to the beginning when we talked about the biological key. And so I didn't necessarily expect you to, with your lab, to identify the trees. I mostly just wanted you to be able to come up with the characteristics of the leaf. So Emma, if you're watching this, you do not have to figure out what kind of tree your leaves came from. I just want you to be able to describe the leaves based on their shape. But when you have a biological key and you have a leaf, the questions to identify, to figure out what tree it's going to come from, are going to be a lot of what is the leaf shape, what is the edge like, what kind of leaf mosaic pattern does it have, what's the margin, what's the venation. Those are going to, and we're not going to do that, but we've done the biological key earlier, and you remember how you ask the questions and it takes you, and then eventually it takes you to that species. And so that is how you would be able to identify a tree from the leaves, observing what the stem or the stalk look like, just making general observations, and then answering the question about the biological key, and hopefully being able to figure out So we've got a lot of different shapes, in figure 14.4 on page 433. Again, I think there's probably others. This is probably not a complete chart. This is probably kind of the most common ones. I want you to kind of have a general understanding. I'm not planning to ask you, like, put some obscure leaf on there and say exactly what shape. You don't have to have every one of those names memorized. But what I do want you to know is that there are charts that exist to help you match up. And so, you know, in your life, if you want to identify something, you can always get on Google, look up leaf shapes. You can find a biological key, also online, and that can help you identify what something is. So you have the skills with your eyes, the internet, and biological keys to figure out any kind of tree. You buy a house one day and you don't know what the tree is. You make observations, you get on the internet, and you figure out what kind of tree it is. Okay?
Wonderful, so help.
All right. So with the what shapes did you guys have on your leaves? Pull out your stuff now. We'll talk about that for a minute. Here, Martin.
Do you want us to like pass this around?
This looks good. Okay. All right. So this looks like a piece of ivy. This came off of ivy.
Oh, you missed the page.
Okay.
Oh, you put them in your notebook?
Yeah, that's how
You're
you're
supposed
supposed to do
to.
it.
Won't they just like disintegrate after a little bit?
They probably
You have
will.
to press them like if you press them in like a really heavy book, then they won't.
Those aren't pressed though.
Yeah.
Hey, you can press them.
Oh,
like,
look
just
at
put it
this
in
one.
between heavy
So
book.
this
I
one's got
did.
the undulating.
So they are pressed.
I don't think those are pressed.
They are.
Okay.
And this one?
Okay, that has a
Serrated.
serrated margin. So you think about a serrated knife, like a bread knife, it's got the tiny little points. This was actually a really good lab, and I think it was a great lab, but I really wanted to give you guys time, so, but I think this is a great lab, it's a good one to do at home. Okay. Oh, look at that one. That's got a different edge on it.
I know.
Like, I don't know what my own leaves look like. What does it look like?
It's not, and you know, this also is a little bit hard because the trees haven't completely leafed out right
I
now.
actually want to specific.
Just rip out the page.
Well, yeah, but
Usually
before
the
I thought of that, I already
Okay.
pieced it together.
Why don't you write a little more on your conclusion? Okay, let me see.
I have 3 sentences.
Oh, good.
Just make it sound like you're passionate about what you're doing.
Honestly,
So
so
that was one from the fall, I guess, that had fallen.
whenever I started it, kind of.
Yeah, you broke off some of it, yeah.
Like I opened it up and it was like it just felt super good.
You're good.
That's how
Oh,
you
wow.
make it sound
That was
sensitive.
cute. Okay, good job. All right. Good job. Thank you guys for bringing it. All right, so we can identify the leaf from the shape, and then if you turn to page 434, you can identify it from the leaf margin. And so I saw an undulate and a serrate. Did anybody have a crenate, which almost looks like a scalloped?
Man,
Did
had
anybody
an
have that one?
I had an entire
There's some of those at Milliken. You know, like the ginkgo trees, but that's like ginkgo trees. Yeah, have like the.
I think they're the ginkgos. Ginkgo.
I have a ginkgo tree in my yard, but I don't think it's,
Oh.
I wouldn't say it's crenate.
Does it have that wavy thing at like the top of this like triangle thing?
I mean, the whole leaf, it's got kind of a funny shape. I don't know that it would fit any of these shapes.
Yeah.
But I think the edges are I think the edges of it are smooth. I mean, but you know what, mine hasn't leafed out yet, so when it leaves out, we'll get some leaf.
So, like, for these, like, for dentate and stuff, like, does the whole thing have to be dentate? What happens if part of the leaf is smooth? Like, has an entire margin? What do you call it?
If part of the leaf is.
Yeah, what if part of the leaf is entire, and part of the leaf is dentate?
Even though.
I don't know. I would think that it would be, I don't know.
Printate? Maybe it was both.
You find me a leaf like that. And then we'll use the biological and figure it out. Okay, and then we also are going to be looking at the venation, so that's gonna be in figure 14.6. And so those are like the veins, venation veins that run through the leaf, and we've got the parallel venation, so there's gonna be straight lines running down. The pinnate, which you're gonna have one mid-rib, one mid-vein coming through, and then the branches are gonna be coming off of that. And then the palmate is gonna look a little more netted, because you're gonna have the mid-rib, you're gonna have branches coming off the mid-rib, and then more branches coming off of that. So probably, my guess is that a wider shaped leaf is gonna be more likely to be palmate, because you're gonna need more little branches coming off of it. That's my guess. Okay, so let's look at the on your own on 14.4, and Solomon, why don't you tell me what you got for A?
Well, the shape would be deltoid, right?
Mm-hmm.
The margin would be serrate,
Mm-hmm.
and then the venation would be pinnate.
Good. Okay. Who's gonna take B?
I can take that.
Okay, Ellery.
It is lobed,
Mhm.
undulate, and palm.
Now, I got entire for that one.
I got entire too.
I think it's,
So
yeah.
lobed is the.
Yeah, lobe is that shape.
Okay.
Yes, okay. Okay, but I understand why I can see how you would get that. Okay, C. Who's gonna take C? Amy Lynn?
It's cleft, palmate, and looks entire maybe? Either that or dentate.
Dentate. See those little points?
I mean, I see.
So it has, I would say this kind of goes back to Naomi's question, actually, looking at that leaf. I think that if it has any dentate on it, then it would be dentate even if some parts were smooth. I think you would classify it as, see that leaf, see how the bottom part looks entire? But the top looks dentate. I think you go with, if it has any serration, you go with that serration, even if there's some sections that are smooth. I think that's the answer for that. Okay, what about D? Who's got D? Naomi? You got
The shape is linear,
Uh-huh.
the margin is entire, and the venation is parallel.
I actually, the first time I looked at that one for the venation, I put undulate.
I did that too.
And then when I went back and checked the answer, it said,
It was like wavy.
right, but I can understand why somebody
Yeah, it
would.
was
but
like
the
you're
leaf
tricking
itself
us.
was good. Yeah, that one was a little unclear there. Okay. Okay, so let's now turn to page 436. And we're looking at the microscopic structure of a leaf under a microscope. And what do we have on the outside of both the top of the leaf? So this is a leaf like this. So we've got the top on the top and the bottom on the bottom. What is that outer layer of cells on both the top and the bottom called? Ellery?
The epidermis.
The epidermis. Okay. Now, tell me how the CO2 gets into the leaf so that photosynthesis can happen. How does it get in there, Ellery?
It actually goes through the bottom, and there are, the stoma are what receive the CO2 and distribute it throughout the leaf, but they are guarded by these guard cells that can open and close according to whether or not the weather is right to receive CO2, which I think is part of why it's not like the main producer of oxygen, is because it's not constantly taking in CO2 and distributing it. Like, it's not
That's a good
constantly
observation.
releasing oxygen.
Okay, that's a good observation, I like that, okay. So, I think of the stomata or the stoma, those are the holes where the CO2 can come in and the oxygen can go out. I think of those kind of like spiracles. So we were talking about spiracles with some of our fish and with our arthropods and some of our insects. They're kind of like holes for gas exchange, okay? And yes, there are guard cells right there that can open and close. And those guard cells are gonna open and close depending on conditions, okay? And so when the guard cells are going to, hold on one second, let me make sure I'm telling you this all right. So when the light levels are low, the stomata are gonna be closed. When the light levels are high, they're gonna be open, okay? And when the light levels are high, the photosynthesis is happening, and when photosynthesis is happening, the plant is producing glucose. We're going right back to some of that information from the first semester that Amy Lynn enjoyed so much. Okay, so the plant is producing glucose, which is a sugar, and when you get a higher sugar concentration in that cell, what do you think happens in that cell when you've got, you think about you're building up, think about osmosis and diffusion, you've got more sugar in the cell. This actually is not in the book, this is just me hoping y'all are gonna remember something from last semester. So you get this higher sugar concentration in the cell, and what do you think happens?
Does it swell?
Is when water moves in. So that causes water to move into the cell. So that's gonna cause that cell to swell. When that cell swells, it opens, okay? The stomata, the stoma is going to open. In low light conditions, when there's not as much photosynthesis going on and it's not producing the sugars, there's not going to be as much water in the cell, and so that's going to cause the stomata to not be as swollen, and it's actually going to close. Okay. All right. Why would the stomata need to be closed? How is that offering protection?
Well, then nothing else gets into the leaf.
Okay, that's a good guess, but that's not exactly what it is.
So why does it evaporate?
Right, so it goes back to transpiration from our ecology chapter. And so it keeps the water in the leaf, in the plant. Okay. All right, any other questions about that? Okay, so now we've looked at our epidermis, we've looked at where our stomata, our stoma is, and our guard cells. And then we've got that densely packed area under the top of the leaf, epidermis. And what is that called and what's going on there? Emma?
I don't remember. Can I go to the restroom?
Oh, sure. I'm sorry. That's okay. So that kind of up under the top of the leaf, that top epidermis, what is that section called? And who knows what is going on there?
Is it the palisade mesophyll?
So that's what I'm looking at. I'm looking at the palisade mesophyll.
Sorry, do you
Oh, no, you're right. Do you know what's going on there?
It's gonna be doing photosynthesis, right?
Yes.
Okay.
Yes, so it's gonna have a lot of chlorophyll in it, and it's going to be doing photosynthesis, okay. So, and it's very densely, that area is very densely packed. So you think about all those little chloroplasts, and they're densely packed. How are all of those chloroplasts catching light. Do you remember, Ellery?
Cytoplasmic streaming.
This cytoplasmic streaming. And I can't remember, but in first semester, we have watched a video, and it was some kind of, it wasn't a plant. I don't know which kingdom it was from. I don't know if it was maybe from Protista,
I think it was like bacteria.
Bacteria,
It was some kind of
Monera,
bacteria.
where it showed cytoplasmic streaming. So that's like the cytoplasm that gel within the cell, and you've got all those little microtubules and microfibers causing movement of the organelles within the cell. And so those chloroplasts are moving around to catch the light, to maximize their catching the light with cytoplasmic streaming in that palisade mesophyll. And what is the area under the palisade mesophyll that looks a little more loose with like kind of some gaps and holes in it? What is that called? And it's named appropriately because it's named after something that has gaps and holes in it. Ellery?
The spongy mesophyll.
The spongy mesophyll. And Ellery, do you remember what goes into those gaps and holes? Why those gaps and holes are needed?
Is it water?
It
Or
is-
is it the CO2?
It's the CO2. Okay, so think about it. That is the stoma are on the bottom, okay? And so that CO2 can come in, and it has all those holes in the spongy mesophyll, so it has space for the CO2 to come in. And then in the middle there, we have the vein with the xylem, the phloem, and then the one thing that wasn't mentioned earlier, the collenchyma, which are thick-walled cells that help support the vein of the leaf. Okay? All right, any questions about that? Okay, we're gonna move on to 438 and 439 and talk a little bit about colors and leaves falling off the trees. Okay, so what makes leaves green?
Chlorophyll.
Chlorophyll. Okay. What about plants that are yellow and orange? What is making them yellow or orange? Is chlorophyll the only kind of substance that's giving color to our plants? Solomon?
Is it carotenoids?
Mm-hmm. So carotenoids are what makes carrots and sweet potatoes and pumpkins and squash the color that they are. And carotenoids and all of the different colors that come in fruits and vegetables are also, and this is the benefit of having a teacher who's a dietitian, they are also nutritionally so good for us and help prevent a lot of diseases, which is why it's so important to eat a variety of fruits and vegetables throughout the day, every day, and eat a lot of colors. And we know a lot about the benefits of the different carotenoids, but we don't know everything. And we don't know that certain carotenoids kind of interact with certain vitamins and minerals and help us absorb them better. And so when people say, well, I don't eat fruits and vegetables, I just take a bunch of vitamins. Well, you don't know what's in your food that's helping you absorb all of those vitamins and minerals. And carotenoids have been shown, carotenoids and other colors like the anthocyanins have been shown to actually help with absorption, so it's important. Yes, Marina?
Does that mean like those like red and orange leaves like are good for us, like if we eat them?
Like the red and orange leaves that fall from trees? No, just stick with the food that's red and orange. Just stick with, okay.
Well, like teas though are.
Right, teas are different, yes.
These are like green juice.
But, you know how in here it talks about how teas, have the tannic acid in the teas. And tea is good for us, but we can also overdo tea. And tannic acid can actually bind to iron and not allow the iron to be absorbed. And so when I was a dietitian at the health department working with kids, and it was a lot of, kind of like lower income families that would come in. This was when I was in graduate school. We would have young kids that would get sweet tea in their bottles, that were drinking a lot of tea, okay? And well, we always, at the health department, we check their iron levels, and a lot of these kids, I mean, you could even tell like under their eyes, they kind of had like bluish color. They were iron deficient, and my guess was that it had a lot to do with them drinking tea. So it really is not a good idea to drink tea all the time and to be giving little kids tea and really even to be drinking sweet tea. You know, that's like drinking soda all the time. So just, you know, you need to limit the sugar, but just even if you're drinking, I actually drink unsweet tea. My parents were Northerners, so when we had tea at home, iced tea at home, it was unsweet, and that's what I like. That's what's refreshing to me. But it still would not be a good idea to be drinking tea all the time. We need to be drinking water and other things too. Okay. All right, so let's talk a little bit more about the leaf color. So if a leaf is green, could it have carotenoids in it? Yes, okay. It's just that the chlorophyll overwhelms the other colors, and so that's what's gonna shine and show, so that's what you're gonna see, but it still could, okay? And so then we have another category of pigments called, are y'all okay?
She was just choking earlier.
Oh.
Like really bad.
Well, I was coughing because I just swallowed something the wrong way. But
I can do that. So we have the anthocyanins, okay? And those are pigments also. And they're going to be different colors depending on the pH, okay? So if you have the blue hydrangeas in your yard, like they get the big blue fluffy flowers on them, those are very pH dependent. So those are going to be, the anthocyanins are going to be make like your purples, your reds, and your blues, okay? And so if those are in an acidic pH, you're going to have a really good blue color. If they are in a more basic pH, it's going to be more pink purple. And so I have a lot of those in my yard. My yard's really wide. And on one side of I have this like wide screen porch off the back. And on one side of the screen porch, the hydrangeas are blue, just blue, blue, blue. And then as you go further in my yard, closer to the other side of the yard, they get like purple, and then they eventually get pink. It's very interesting. And so I have in the past fertilized them with the acid fertilizer, and you know, can get them all blue, but it's kind of cool to have all the different colors. So that's what the anthocyanins are. All right. So let's talk a little bit about leaves falling. Do leaves fall because it's cold outside? Is that why they fall? Why? What is the signal to a leaf to fall, Emma?
When the days get shorter.
When the days get shorter. So you can have a plant inside your home that will have that's deciduous, okay, that will end up having leaves falling off of it when the days are getting shorter. Okay, so it does not have to do with temperature. What is kind of an important part of that process of the leaves falling? What kind of cuts off flow to the xylem and phloem as the days are getting shorter? Anybody remember what that's called, that kind of cuts the flow off? The xylem and phloem, Ellery?
The abscission layer.
The abscission layer, okay? So it's gonna cut that off. It's gonna begin, the leaf's gonna begin kind of cracking, and eventually the weight of the leaf will cause it to fully crack and break off. And so when that abscission layer, when that happens, it's cutting off the chlorophyll from getting, it's like affects the chlorophyll. And so that allows other pigments to, also kind of shine there. That green's gonna fade away and you're going to have other pigments. And the weather and conditions do kind of affect the pigments. So if you've got sunny, cooler autumns, you're gonna have more reds, yellows, and purples. But if you're gonna have more cloudy, warm autumns, you're not gonna have the same kind of vivid colors, okay? All right, and so that brown in the leaves, so some leaves are not gonna have other pigments in them, and they're just gonna have the brown, and that's the tannic acid, okay? And that's what I was talking about, that combined to iron that's in our teas, which is why we, and teas have a lot of good benefits too, so I'm not like against tea and I drink tea, but you know, you do wanna be careful of the sugar and you don't wanna overdo tea, and little kids don't need to be drinking tea.
So what about plants that like, I mean, like we've got household plants that are like kitchen, like basil and mint. Why don't those lose their leaves? Is it?
Well, those are more gonna be like the basil and the mint. They're just gonna kind of die out at the end of the season. So basil is typically just, I think, goes as an annual, but the mint typically comes back. Is that kind of what you
Mint
know?
always comes back.
Yeah,
And mint sometimes lasts through the winter here.
right, you're right, it does.
Is it just that the
I guess
whole
it's
thing is
not
not-
deciduous, the whole thing's gonna, yeah, the whole thing's gonna die and come back. I'm sorry that I can't give you the exact scientific reasoning behind that. Okay. So let's look at 442, the on your own. Okay, there are a few leaves, such as the floating leaves of a water lily plant, in which the stomata and the spongy mesophyll are on the top side of the leaf, while the palisade mesophyll is on the bottom. In these leaves, which side will have the darker green color, Miranda?
The underside.
The underside. Why is that?
I have no clue.
Okay. All right. So why would it have a darker color, Ellery?
Is it because the chloroplast is so tightly packed that there's just more pigment on that side?
So the palisade mesophyll layer, which Emma, you missed some of this. I felt like you missed like some of the most important little minutes of
I'm
class
sorry.
before. I hate that you missed that. But so and I'll post a video, so if you even want to go back and fast forward to that one spot, you can. But that palisade mesophyll is going to be the tightly packed area with the chloroplasts, where the cytoplasmic streaming is going to happen. So wherever you're going to have the most chloroplasts is where the darkest green color is going to be. Okay, 14.9. If the leaf isn't green, does that mean there is no chlorophyll in it? Emma?
Not necessarily, because there could just be more like concentrated pigments that could be covered.
Exactly. If a leaf has no abscission layer, what color will it be all winter?
So it'll be green.
So probably the basil and the mint don't have abscission layers too, so that would be one reason, one thing that would be affecting it. Okay, so we've got like 15 minutes of class left, and what we're gonna do is I have made a copy of the module summary. And I'm going to give it to you. You guys can work on it together, so you can go ahead and do the part of the chapter we've covered, which is 1 through 6, although most of number 4 we haven't covered, so you can skip number 4. Some of number 4 we've covered, but not all of it. Not all of it's been covered in the book. But you guys can work on these together, and that way you'll have some work knocked out for next week. And I would say you have this, and as you're doing your reading each day, go ahead, when you've read that section, go ahead and fill it out, and then since you're not studying Quizlets, I need to take that off the assignments for next week on the days I put Quizlet in. Go back and read through and study your Appendix B.